Hello everyone, so I'm Sonal. Today I will introduce you to BJT. This is analog electronics topic. So BJT. Full form of BJT is bipolar junction transistor. So it was invented in December 1947 by John Bardeen, Walter Brittain and William Shockley at Bell Laboratories, USA. John Bardeen, Walter Brittain and William Shockley. He was actually the head. He invented junction version of transistor later on in 1951. So, they received Nobel Prize in 1956. Actually, transistors replaced bulky vacuum tubes. BJT is a three-terminal device and it's used in amplification of weak signals and switching operation. So basically there are two main principles of BJT. First is amplification and second is switching. It acts as a switch, on and off switch. So I will start by introducing you to the physical structure of BJT. So it's a three-terminal device. N, P, N. This one is ammeter terminal. Three terminals are there. Ammeter terminal. This one is base terminal, or you can simply call it base, and this one is collector. There are two junctions, ammeter base junction and here ammeter collector junction. This is your ammeter region. This is your base region and this is your collector region. Now BJT are of two types, NPN and PNP. This one is NPN. PNP is also similar to this. PNP. Base, collector, ammeter. This is your ammeter. Here you have ammeter base junction. Here you have ammeter base collector junction. This is your ammeter region. This is your base region, and this is your. So your largest region is your collector region. This one. And your smallest region is your base region. Collector region is large because it is where the electrons are collected. Electrons come from ammeter, it passes through the base and then they are collected at the collector region. And your base region is smallest because recombination takes place in base region. For example, this is your NPN, right? So here majority carriers are electrons. Here also majority carriers are electron. P, your majority carriers are holes. So when electrons will travel from ammeter to base, there will be recombination in this base region. Electrons coming from ammeter will recombine with holes in the base region. Some electrons will combine here, some will pass through. You can reduce the amount of the electrons recombining with the holes if the base region is small. Then low recombination will be there, right? Collector region is large because here electrons are collected. So electrons are collected, so heat is produced, and larger width means better heat dissipation will be there. So basically, in terms of width, collector is largest, then you have your ammeter, and then you have your base. You know what is doping, right? Doping is addition of impurities. So in terms of doping, your ammeter is largest, then your collector, then your base. So base has less width and less doping, so that there will be less recombination, because we want majority of electrons to go to the collector region. And your ammeter has largest doping because electrons are going from ammeter. So more electrons, if more charge carriers will be there in ammeter, more charge carriers will reach the collector, and that's what we want. So doping of ammeter is greater than collector, and then it is greater than base. I hope you understood these topics. I will discuss more topics in the next video. Thank you. Kindly subscribe to my channel. Bye.